So we're going to be looking at what is called the fundamental theorem of calculus today. So I already wrote part of it. You can pause it and write that part. If you have a function continuous on the closed interval from a to b, and we can figure out the antiderivative, then the fundamental theorem of calculus says if we evaluate the interval, the integral from a to b of f of x, we can find that by taking the antiderivative and plugging in the endpoint minus the other endpoint. So this is called the definite integral. It's got actual values. It's evaluating the antiderivative, or what we call the integral. But we want to understand what this means, what we're actually finding, right? Okay, so this is called a definite integral. I want us to look at this function, negative 2x plus 3. What is the antiderivative of negative 2x plus 3? Well, we've been doing that. That's going to be negative 2x squared divided by 2 plus 3x to the 1 divided by 1 plus some constant. And what we're going to do is we're going to evaluate that between negative 2 and 1. What that means is we're going to plug in 1, and then we're going to plug in 1 minus what we get when we plug in 2, negative 2. Let's simplify that a little bit. That'd be negative x squared plus 3x plus c from negative 2 to 1. So I'm going to plug in negative 2. Or actually, I'm sorry, plug in the top one, plug in 1. So negative 1 squared, or that's 1 squared, plus 3 times 1, plus c, minus what we get when we plug in negative 2. So I get negative 1 plus 3 plus c, and that's going to be minus negative 4 minus 6 plus c. Distribute the negative. So it's plus 4 plus 6, minus c. 2, the c's cancel, plus 10, that's 12. An integral in terms of area is something we looked at last time. It's the area under the curve between negative 2 and 1. So we're talking about this area right here. And that's a trapezoid. It's a trapezoid if you turn it sideways. So the area under that curve is going to be the average of my bases. So that one's 1 plus, that's 7, averaged, times this width, which is 3. So that's 8 divided by 2 is 4 times 3. My area under the curve is 12. Oh, it's the same thing. What about from 2 to 5? Okay, so we already know what the antiderivative is. But this time we're going to evaluate it between 2 and 5. So plugging in 5. And then plug in 2. So that's negative 25 plus 15 plus C minus a negative 4 becomes plus 4 minus 6 minus C. So these cancel. Let's see, that's a negative 10 minus 2, that's a negative 12. Let's see what that means graphically. From 2 to 5, so we're talking about this area from 2 to 5. So that's a trapezoid, but this is a negative value, so we got negative 1 and a negative 7 divided by 2 times the width of 3. That's negative 8 divided by 2. That's also negative 12. So the fundamental theorem is giving us a shortcut on finding the area on the graph. So negative 1 to 4. We're talking about the area here and then the area there. Well, if we think about it logically, that would be a positive area. This would be a duplicate negative area. Let's see what happens when we plug in here. We know the antiderivative. We're evaluating between negative 1 and 4. So when I plug in 4, minus plugging in negative 1, I get negative 16 plus 12 plus C. So negative 1 squared is 1, but that becomes negative and then another negative, so plus 1. It's a negative 3, but we're subtracting it, so that becomes plus 3. And then minus C. What's happening to those C's every single time? So notice when I evaluate the definite integral, I get a 0, and this area should cancel out with that area. So it works. And those C's are always dividing out every single time. Or canceling out, not dividing out. This time from negative 1 to 3. So we're finding this area. Do you think it's going to be a positive or negative area? Let's find out. Negative 3 squared plus 3 times 3 plus C minus negative 1 squared plus 3 times negative 1 plus C. The C's are going to subtract out. That ended up being plus 1 plus 3. So I end up with a 4. There is more positive area than negative area. 0 to 5. Finding the area between here and here. So plugging in 5. Then plugging in 0. C's are going to divide it or subtract out, so we're left with negative 10. Finds the area of the shaded region. So what happens is, the first thing, that definite integral finds the area of the region bounded by f of x and the x-axis. The second thing we noticed should be that this integral will be 0 if the area above equals the area below the x-axis. The integral is positive if the area above is bigger than the area below. And we get a negative answer if the area below is bigger. So next are some practice problems. Try them, then play if you want. Let's see. So I need to find the antiderivative. We're evaluating from -1 to 2. And the C is going to subtract out anyway, so I'm not even worried about him. So that gives me 4. Whoops, that was a 3. Minus 2 cubed is 8 divided by 3. It's a positive 1, so minus 1. It's a negative 1, but we're minus, and then a minus, that's still negative. That gives me 3 and negative 9/3. So 3 minus 3 is 0. The next one, I noticed something interesting. This one, we have a possible problem. To use the fundamental theorem of calculus, we have to be continuous. And notice that we have a bad spot on our domain. So this does not exist because FTC is not applicable. Since is not continuous at x equals 0, which is on the interval from -2 to 3. So we would have an asymptote there, which means our area wouldn't be possible to be found. Okay, what about this one? This one would also be discontinuous at 0, but that's not in our interval. So this one is doable. First thing I would do is to rewrite it. That's going to give me 2 over x plus 3 over x squared, which I'm going to rewrite as this, so that I can take the integral. That's the weird one that turns out to be ln x. And that's going to be, when I add 1 to the exponent, it's going to give me a -1 plus c. And then we're going to evaluate 1 to 4. So I get 2 ln 4. That's going to be a -3 over x at 3 over 4. I don't care about the c's because they're just going to subtract out. When I put in the 1, minus 3 over x. So let's see, 4 minus 3/4. Natural log of 1 is 0, so 0. That's going to be a plus 3. So I got a minus 3/4 plus 3. Let's change 3 to 12/4. That gives me 9/4. 2x plus cosine x. This is a good one to practice. Antiderivative of cosine is sine. We're going to evaluate this from 0 to pi. So this is x squared plus sine x plus c, 0 to pi. I get pi squared plus sine pi minus 0 squared plus sine of 0. Well, that's pi squared. Sine of pi is 0 minus 0. Sine of 0 is 0. So I get pi squared. What about from a table? Ooh. Okay, so this says what is the value of the integral from -3 to 1 of f prime of x dx. So that's the derivative. So its antiderivative would be the original function. So if I'm taking the antiderivative of f prime, that's going to just give me back the original function evaluated at 1 minus the original function evaluated at -3. So at 1, the original function is -2, and at -3, it's 4. So I get -6. Ooh, okay, so the integral of f prime plus f double prime. Well, that looks scary. It's not. The antiderivative of f prime would be f, and the antiderivative of f double prime would be f prime. some brackets around these. And we're evaluating that from -1 to 3. So in other words, I want to plug in f of 3 plus f prime of 3 minus f of -1 minus f prime of plus f prime of -1. F of 3 is 1. F prime of 3 is 3 minus f of -1 is 0. F prime of -1 is 1. So I get 4 minus 1, which is 3. The antiderivative of f double prime is going to be f prime. And then we'll just multiply that by 3. Evaluated from 1 to 5. So 3 times f prime of 5 minus 3 times f prime of 1. That's 2. And that is 0. So I get 6. The antiderivative of half of f prime is going to be half of f of x plus antiderivative of 2 times f double prime is going to be 2 f prime. And we're evaluating from -3 to 3. So the first thing I need to do is plug in the 3. Then plug in the -3. If I look at 3 in the original function, it's 1. And 3 in f prime is 3. F of -3 is 4. F prime of, -3 is -2. So I get 1/2 plus 6 minus 2. So that's that's a -4 plus 4. That's -4. What was I thinking? So I've got, that's -2 plus 2. That's 8 plus 1/2. So that's 8.5. What is the equation of the tangent line at x equals 3? Oh my gosh. So let's see. F of 3 is 1. That's my point. F prime of 3 is 3. That's my slope. So y minus the y value equals slope times x minus the x value. Use this equation to approximate the value of f of 3.1. So to approximate it, let me rewrite this. That's going to make it easier. Okay, so it's approximately 3 times 3.1 minus 3 plus 1. That's going to be 0.1. So 0.3 plus 1. So it's approximately 1.3. Now, how would we know if it's an over or underestimate? Well, let's look at the second derivative at 3. Well, it was negative 3, which is less than 0. So f of x is concave down at x equals 3. So if it's concave down, then any line we draw is going to be above it, which means this is an over approximation.